today, I'm gonna be like, no, back. Sit down.
And my request is that you guys, most of you had me before. Do you know what the I love you but moment is? Oh, no. I need to explain the I love you but moment. Okay, not to those two, clearly. See, I am an extremely sensitive human being, so is my family. For the story before, I apologize greatly. But whenever the rule is in my house, when you're about to give somebody constructive criticism, you have to say, I love you, but first, and then you can tell them their constructive criticism. Okay. I cannot ask you guys to stop talking a million times during class. I can't do it. Can't do it. So there's this whole thing about like social awareness where you notice when someone else, the person who's like in charge is trying to do something, and then when it's appropriate for your group to talk, and then for when the teacher talks, and then you look over here like, oh, she's trying to teach, I'm not going to talk now, this wouldn't be a good time. And then you stop talking and I talk to see how that works. So just because it's a block day and I don't have it to do that for an hour and a half. Also, there are there are several students who really want to raise their grade. And if you're getting in their way, that is not good. So please don't steal someone else's opportunities to learn. Okay, so, but that being said, we're actually going to do a little bit of chapter 3 review first. This particular lesson, again, has 3 big parts. So we're going to start with big part number 1. And if you've been struggling so far, I'm hoping this will help and you can tell me if it's helpful. If you could go in your packet and find the page that says regression output notes at the top. And then grab a highlighter or something if you want to. It's not required. And just highlight those 4 things. Okay. And I realize that I probably caused some of the discussion because I say, hopefully funny and quirky things. I'm about to say a funny and quirky thing now. So here's the thing. We were just talking about TI 84 calculators, but when you're like, say, a 40-year-old dude, like doing your accounting job, you're not going to be whipping out your TI 84 from your briefcase. If you're a market analyst, you're not going to be like dragging your TI 84 out, in your fancy desk on the plane, like, on your long flight from LA to New York while you're working. So there's actually software that does all of these things for you. But we're going to look at Desmos today. Desmos does all of this. This is called regression output, which basically just means that some software program, some other person put all the data points in for you, and it ran all of that stuff for you, and it's done. So regression output is a happy thing. That means that somebody did all the work of entering in the scatter plot, and you just have the end result. Yay! Yay! Okay. Now, we're going to spend some time on this page. We're going to review quite a few things from the chapter. So again, if you've been struggling, I'm really hoping that this will help. The first thing that you need to know is that this word constant means constant. Okay, I know I'm being funny. So y hat equals a plus bx. Which one of these things in the line equation is the constant? A. So this number that's next to the word constant is A, which is your y-intercept. this number here is two things. It's the slope, but it also tells you what the explanatory variable is. Let me say that again. This number is the slope, and this label tells you what the explanatory variable is. So you come back up here and you're like, oh, that means this is the X and this is the Y. Okay, so that means the equation in this problem is y hat equals 1.79 minus 0.21x. Does anyone have any questions about that? Okay, now on your homework tonight, I was working on it in Access with a student. There's a problem that has output like this, and S is called the root mean error. I've never seen it like that before, but it kind of makes sense if you think about the formula for S. It's that big root, remember, with the like stuff underneath. So just keep an eye out for that in your homework tonight. When it says root mean error, that's the one that's S. Anyway, okay, now we're going to practice sentences. We're going to do 5 sentences. Those are the part, like annoying part about the chapter, but it's really important. And the first one we're going to do is slope. Okay, so write slope right there. One thing that I'm noticing about my AP Stat students this year is they are not really connected with the notes in their notebook. So what I want to do is go back to where that slope interpretation sentence was. The next one we're going to do after this is y-intercept, so I'm just going to leave this up here. This is in the section 3.2a. Okay, for every increase in one x, we predict an either increase or decrease of by. Okay. For every increase in one, okay, and what is the x in this problem? Time without math, yep. And notice they didn't really give us units for time. It's kind of awkward, but it's okay. For every increase in one time without math, comma, we predict an okay, so here's your next decision. Is it increase or decrease? Decrease, right? Because the slope is negative. Oh, it wouldn't be and then, huh? That's awkward. Don't tell Mr. Baker. Okay. We predict a of 0.21 happiness. I don't know how they rated time or happiness here, but we're just going with it. I also really picked this probably because I thought it was kind of ridiculous, you know, like it kind of silly. Okay, any questions about how to interpret the slope? Okay, now we're going to do y-intercept. Y-intercept. At 0x, we predict a y. At 0, time without math,
we predict 1.79 happiness. Okay, are there any questions about how to interpret the slope or y-intercept? Before I move on to the next one. Okay, all right, now we're gonna go back to do correlation, which is the one from last Friday with the, we only wrote that one sentence in our notebook. And first thing we need to do is find R. That's actually a number. Okay, so what you're gonna do is you're gonna look at your output data and you see this one that says R squared. That's literally R squared. So R squared equals 0.3955. Change it to a decimal first. Square root Okay, now who had me for math 3? You're like, oh no. What did I hammer in your head about when you square root both sides? Plus or minus. Beautiful. Okay, so this does not, that does not go away here. This is definitely plus or minus. However, you need to think about it because you can tell whether or not it's plus or minus from the problem. What is this one? Minus, because the slope is minus. Okay, so the reason I brought that up was because I wanted you to be like, square root both sides, plus or minus. What is it? And notice I left that little space on purpose. So the slope sign needs to match our sign. Okay, now go back to that sentence that you wrote, which is your 3.1b. Nope. There is a strength, direction, linear association between X and Y. Okay. There is a, what about 0.62? Strong, moderate, or weak? Moderate. Okay, notice I put a big question mark, big ugly gaping line and question mark. Why did I do that? Right. Did they show us a graph? Do you guys see a scatter plot? Do you see a residual plot? No, those are the only ways you could tell the form. So Remember, I picked this page, this regression output for happiness versus time without math. I picked this on purpose because I thought it was silly, but also because I wanted you to have the same analysis of it that I did. You can't just go by the numbers. You have to see a picture. Okay. Next one, S. We have two more. S. S was in our most latest notes. And then we're going to do R squared right after that, which is going to be the same page. The typical distance between the points on the scatter plot and the least squares regression line is SY units. Okay. Thank you. I think happiness is a clean airway. Maybe not time without math. Okay, now you just wrote a sentence because I told you to. You're like, great, I can fill in the blanks, Mrs. Talbot. What is this one actually saying? What is this telling you about the picture? It's not necessarily saying that it's linear. It's something good though.
It's close.
Yeah,
Yeah.
all the points are close up to the line of best fit. Okay, so like for just to contrast that, the S for our class was 4. Yeah. So we on average we were 4 starbursts off the line. This is super small decimal, which means that those points are like really on that line, really close, which is good. That's a good thing. Okay, last thing, R squared. R squared percent of the variability in Y can be explained by a linear association with X. In this case, we're going to put a little, hoping that it's linear. Not really sure. Okay, so R squared is right here. So 39.55% of the variability in happiness can be explained maybe. That's a not yes or no, it's a maybe.
Gotcha. Don't know. Awesome. And this is the reason that I like this dumb data so much, because I'm thinking like, this is saying that 40% of whether or not you're happy has to do with math. I'm pretty sure that that's probably not the case. It might be a tad of an exaggeration, but what I wanted you to do is be able to see how the sentences work with anything. Okay, was that helpful? So that was my review of the stuff we've done so far in the chapter. Okay. Yeah. Okay. So real quick, let's go back one more step to do dogs. And this is something we're building on in this case. Direction is what in this particular problem? Negative. So direction is positive or negative. Okay. And in these problems, I'm going to say, what is it? And then you have to state a reason. You have to give a justification or evidence. You could say the slope is negative, or you could say R is negative. Either one of those two. Does that make sense? Okay. O is outliers. You have no information about outliers. You got nothing here because there's no picture. Okay, so you can't say anything. 4, also you don't know. There's no picture, no residual plot, or nothing. Say strength, moderate, and you would say because R is negative 0.6289. Everybody good? Okay. All right, so, oh yeah, strength is R, so you say moderate because R is negative 0.6289. So it's in the 60s. And we said on our slides, what did we say? Moderate was what to what? 0.5 to 0.7. Okay. Do you see how I'm trying to tie multiple lessons together? Okay. I'm trying real hard. Okay. Now, that is the first part of today's is done. Back to this. Okay, so I'm going to tell you the first part of the lesson was review, except for identifying those numbers from the software out there. This part is easy. Very, very easy. It's algebra 1. It's great. You're going to like it. The only problem you're going to have with it, like other things in this class, you don't know when it is. Like a problem will give you some stuff and you'll be like, which thing is it? That's the problem. But I can give you a good hint of when to look for this. But anyway, and then the third thing is kind of spicy. So just spicy. That means a little bit challenging. Okay. Poor child's never had me before. So Harrison, do you see the salsas over there on the wall? So those are mild, medium, and hot, different type of math problems. So I always use that because I'm dumb. And okay. Do you guys remember how I was saying that like a businessman isn't going to be whipping his TI-84 calculator out in the plane? And then, you know, also they were not getting TI-84 calculators out in like, say, 1950. Okay, so now we're going to take a step back in the past and figure out how did they figure out the line equation back before the graphing calculator. Okay, so we're going to do regression to the mean, and it's a way to do the equation by hand. But every time I say that, people are like, oh my gosh, by hand, no. It's really not bad, I promise you. Okay, regression to the mean is a way to algebraically
find, shh. Again, please stop talking. Or not. Okay, there's a couple of facts that you need to know here. First is every least squares regression line, one of the best parts about it is it goes through the perfectly average point. When I say perfectly average point, I will explain that visually on our graph. But you also need to know, what do you need to find a line equation? I'm going to ask you to channel your freshman math 1 self. What did you need to find the equation of a line? I'll accept 3 different answers. Yes. Slope and, yeah, okay, that's 1. Slope and y-intercept. What else? Slope and 2 points, that's 1 of them. What's the third one? Slope and a point. Yeah. So when you would plug in m, x, and y and solve for b. Okay. All right. So that's what we're going to do here. I'm going to give you 2 formulas. And then we're going to talk about these 2 formulas. Okay, so what I would like to remind you of for math 1 is that you can find the equation of a line given the slope at a point. Slope at a point, right? Okay, this is slope. Let me explain why this makes sense. Standard deviation of y is the change in y. Standard deviation of x is the change in x. Change in y over change in x is slope. However, you don't have a line, you have a scatter plot, so you multiply it by its percent strength. Let me say that again. Change in y over change in x is the slope, but it's not exactly a line, it's a scatter plot, so you have to multiply it by its percent strength. Like averages, yes, yeah. No, not average residual, it's just the correlation, like 60% strength, 30% strength. If it was 100%, you've been doing this your whole math career, it's just that R was a 1. Because it was 100% strength when they were all perfect lines. Right? That's why R is 1 with a perfect line. Yeah. Okay, now this is your usual equation, y hat equals a plus bx, except for that this is the average of x and the average of the y. The average of the x and the average of the y is a point on the line, and you have to believe, you have to trust that before I prove that to you. All of the lines of best fit go through the average of the x's and the average of the y's coordinate. Yes. Exactly. You start with this one. You're going to multiply r by standard deviation of y, standard deviation of x, get a number. And you plug in the x, y, and b and solve for a. Yeah. Okay. So we're going to go to your calculator now. We're going to do this for reals. And you're going to have to wait for me a second because I think I have first period's data in there. Um, I don't know if any of you have seen the Venn diagram that relates the usage of the words for reals in rap and mathematics.
Really?
Harrison got me. It's the only two places that you ever hear for reals is rap music and math, like all real numbers. No? Okay. Now would be a great time for you guys to talk about your day for 30 seconds while I type these in. Nice, nice. You did it. Right. Oh, nice, nice, nice. I like it. Okay. All right. So this is what I want you to do. Get this, turn it on, la la. Okay. Don't go there. All right. So now go stat, calc, and instead of one variable stats, I want you to do two variable stats because we're two variables here. Make sure that your X list and Y list match whatever lists you typed it into. Okay. Notice it gives you lots of good stuff. It gives you stuff about the X's, gives you stuff about the Y's. It does not give you R, but that's okay because we had R from our previous work. Okay, what I'd like you to do right now, though, is go on your warn sheet. That shouldn't require any discussion. Can you tell from your calculator where I got these from? Okay, now since I don't want you to just blindly believe what I'm doing up here, I want you to turn the graph over and see if this approximate point is on the line. It should be. It's like here-ish. Okay. This is my way of showing you that I'm not making stuff up, that the point that is the average of the x's and the average of the y's will always be on the line. Okay. Now scooch back over here. We need 5 pieces of information to be able to do a regression to the mean problem, to plug into this stuff. Okay, now look on your orange paper. What was R? Mhm. Good so far? Okay, so this is where my hint is. You know how like I said that the only problem with these is going to be figuring out when to do this, like what the question will be asking you to do this. It will give you 5 numbers. So when you read a word problem and it's got 5 numbers in it, typically it's this. So that's your hint. Anyway, okay, step 1. Find B.
Will they tell you what numbers they are?
Oh, yeah.
Okay,
Yeah, I mean, like, Mrs. Sabat drinks a lot of iced teas on hot days, and she did a scatter plot of blah blah, and her average and her average. But if it's like word problem in which there are 5 different numbers in it, typically you can line them up with these 5 numbers, and you can
thank you.
Do you guys see what I'm doing?
Yeah.
Just plugging in. No need for parentheses or anything fancy. Just go times, divide. Okay, now I was hoping for a little bit more of an exciting response to that answer. Yeah, you guys see, this is the data I got from the calculator.
Oh, that's
Okay. Okay, now notice my numbers here are a little off. And you might be wondering to yourself, which one should I do? The one that we do in the calculator reads the decimals out really far, so it's way more accurate than this one. This is like back in the day, they rolled out the papyrus and the scrolls, and like
This is what they did. This is going to be susceptible to a lot of rounding. Notice I rounded all the numbers that I wrote down. So I'm rounding off of rounded numbers, which is never good. But it's pretty close. We got negative 9.9, right? Yeah, so it's not bad. It's not bad. It's not terrible, but anyway. Okay. I would really never ask you to do this if you had the data, like all of the points. I would just ask you to do it on the calculator. And again, just making a quick comparison to what we got on the calculator, it's very close. It's off because of rounding, and that's okay. The one that we got off of the calculator before is better. But if you can't do that because you've had a word problem where they only give you these and you have to do this. Okay, that was thing number 2. That was easy. Now we're going to do the spicy thing. It's only hard because there's not a formula. And I know how dearly you love the formulas. Oh, Mrs. Talbot, I do love the formulas, and I like to get x equals 3. Unfortunately, this one takes brain. No, not brain usage. How dare they? Okay. Fair warning, on Friday we're doing logs. So yeah. Yes. Think about, it's basically like, I don't know if you guys remember from math 3 what a log graph looks like. It's the inverse of an exponential. Yeah. So it's basically like, what do you do if it's not linear type deal? Anyway, okay. Okay. High leverage point. Okay, so we're gonna do each of these 3 things separately. Because this is a little bit anyway. Hold on. So excited I can't write straight. Okay, so outside of stats class, what does the word leverage mean? Leverage. Yeah. Influence. That's exactly what I was thinking was influence. And you could kind of, I sort of gave it away with this one down here. But I want to show you, so this is what I prepared for you before you got here. This is your class's Starburst data in Desmos. And you'll see why I did this in Desmos in a minute, but I want to talk about the vocab word high leverage in a visual way, because that will hopefully make it stick in your brain better. So high leverage points are the ones that are outside of the data range, like on the end. And the reason that they're high leverage is because they're confirmation of whether or not your pattern is working or if your pattern is not working. So if you get a point, and whoever this is, I gotta tell you, I'm so happy that you're here, whoever this person is here. Okay, so this Gianna's point here is a high leverage point because we kept the pattern further down the x-axis. This is proof that the pattern is working. It's proof that our theory is correct and our research is correct. So if you're doing a scatter plot for research and you're doing a line of fit, you got one that's far away, but it's still on the line, you're like, yes, that means it's working. Okay, if you had some outlier way off the line, then you're like, oh no, I don't really know. I don't really know if this theory is correct. I don't really know if my pattern is right. Do you see what I'm saying? So high leverage means it's helping you make decisions whether or not your model is appropriate. So high leverage, very high leverage, pretty good. These are just kind of commoners. I'm saying that to make you laugh. Like they don't have a lot of leverage over your decisions. And then when you get back over to here, these are high leverage points again. Because those ones on the outside are the ones that help you decide if you're doing it, you're on the right track. Yes. And if it's starting and ending the line still on the line, then you know that you're like, yes, good. Okay, does that make sense so far? Okay, so now let's talk about outliers. Okay, and these are the points that are going to make you question things. I think I have the largest residual on our graph. I think my point is the furthest off the pattern. Great job, Mrs. Talbot. I don't know. Maybe it's the old lady influence. I'm right here. This is me. It's funny. So I'm going to show you first period's graph a couple of times today. The first one I'm going to show you is, I'm going to show it to you now in terms of outlier. They did not. And it made it hard to teach, but it sort of still worked. Okay, so that point up there, can you tell that one that I did the residual for is an outlier? Okay, and actually we went back and talked to that particular student, and he said he didn't hear me say the directions about stretching your hand out all the way. This point should be further down. He had a big hand. Okay, but this is the type of stuff that happens when you do research. That's the point that makes you question yourself. Like, what happened there? Well, he didn't hear the directions. Anyway, it actually helps me teach, so I don't mind. But anyway, so it's clear, you know, sometimes they're clear, sometimes they're not. I think on our graph, I'm the most off again. But okay, influential points. Okay, high leverage and outliers are both examples of influential points.
an influential point is any point that if removed affects the y-intercept, the slope, the correlation, the coefficient of determination, or the standard deviation of the moving force. So the reason that I actually did the graph in Desmos is because Desmos makes it super easy for me to take a point out and put it back. So we're gonna go back to your data now, and we're gonna take a point out and put it back and see what happens. Okay, and then we're gonna come back to the first period graph for a minute because I told you I was doing the homework with someone in Access, and the homework problem like this is just like this. The graph almost looks exactly like this, so I want to go back and talk about that one. But anyway, okay, so let's go back to Desmos. So we're going to take off the high leverage point first. I know, bye, Gianna. So Desmos is weird though. It won't let me like just take a point off. So what I have to do is I have to take that, change it to the last point, and then take the last point off. Look at me learning though. Okay. So take a look down here. Okay, so I took Donna off, and our stuff is really different. Just by taking off that one point. And so because this is notes, I want to actually detail what's happening here. So if you could just come back to the notebook for a second. Let's put it, we're gonna stick this down here. Okay, so we're gonna do two different points. We're gonna do me, taking off me, and taking off Gianna and see what happens. Okay, so first point is Gianna. She was 13.5, 13. The reason I don't, you know how I always have my notebook set up for you? I didn't have it set up for you because I didn't know what points I was going to take off until like we did the thing. So, and then we're going to take me off after. Okay, let's go back. So everybody list this stuff. Remember the slope is B though. Do you guys understand what I'm saying?
Yeah.
Okay, so A is negative 8.42. B is 1.74. R is 0.68. R squared is 0.46. Okay, and then just leave S blank for a minute. A is negative 8.42. Right here. I know it's, I know, but do you see, like, they're doing mx plus b. Okay. So let's take a look at our stuff that we had. What happened to A? Increased. And what happened to B? Decreased. Okay, so taking out Gianna's point made it go ever so slightly from here to here. It was like this and it went like that. Just flattened out a little bit. Okay, now what about R? Decreased. Which means it became a weaker association. Yeah, a weaker strength. What happened to R squared? Okay, and now we're gonna have to think, we're gonna have to use our brains. This is the part with the brain, what I was mentioning. We don't know what S is, but we can reason out whether or not it increased or decreased. S is the amount of error. If it got weaker, more error. So that means it increased. No, it doesn't do S on Desmos. So we just have to reason out if it would increase or decrease. We know that it would go up because S is bad. And this is becoming worse because it got weaker, so it would increase because it's bad. Okay, now, last thing for the day. We're gonna go back and put Gianna back in and take me out. Okay. All right, so A is negative 10.57. B is 1.87. R is 0.78. R squared is 0.61. And S we're gonna have to reason out. Okay. A decreased. Are these all just gonna be the opposite? Slope increased. Correlation increased. Man, I'm really ruining our data. R squared increase. Am I getting voted off the island? Okay, and because it got stronger, it means that there will be less error. Okay, give you a second and then my joke, I just, yes, and so S is the amount of error. And if your thing is getting stronger, that means less error. Because R increased. So if R goes up, that means the strength increases. It's getting stronger, which means that my error will decrease. Basically, what you need to know is that R squared, R and R go together, and S is inverse. It's backwards. So whatever R squared and R do, they do together. S is going to do the opposite. He doesn't play with the other two. Okay. Joke time. Mm-hmm.
Use the bathroom before we get to the tent.
Okay, please love my joke.
I love it.
I did not. I did not. I just found it at the perfect time.
You ever come up with a math joke yourself?
No, I'm not a joke magician, but I do.
I appreciate you sharing it. There's different components of homework.
Oh, I might have changed it. What is the homework problem?
77, 78. They have 2 extra. I think last year I accidentally put 77, 78.
Well, yeah, we'll take a pass. Oh, yes. You're lucky there.